Today, we are going to be talking about simplifying radicals and the Pythagorean Theorem. Simplifying radicals is something you should have done in Algebra 1 last year, second semester at some point. The Pythagorean Theorem, has anybody ever heard of the Pythagorean Theorem before? Okay, so some of you guys have heard of the Pythagorean Theorem before too. So some of this will be review for some people, others it will not be. But the goal of today is to simplify, add, and subtract radical expressions, and I can use the Pythagorean Theorem to find the distance between 2 points. So let's get started with that. So this is technically a warm-up, but we're just going to go through it together. So simplify each radical. So when you guys learn to simplify radicals, okay, when you learn to simplify radicals, we taught you guys last year in this building to use a factor tree, and we said what times what gets you that number. So you did like a little factor tree for it, right? Well, in this case, it's 1 times 1, right? And you looked for groups of 2, and whenever there's a group of 2, you circled it and you took 1 out. Does that seem familiar to some of you guys? I don't know if some of you guys did that also in middle school. Now, some of you guys probably already know the answers to these, but I'm just kind of doing this now because they're not all going to be perfect squares, okay? So we know 4 is 2 times 2, so the square root of 4 is 2, because we're saying the number 2 is what gets us to 4. If we multiply 2 twice, it gets us to 4. 9 is 3 times 3, which means we have a 3 out. So let's keep going through these then. You guys probably could just tell me the answers from here. So I'm just going to go around the room. So Carmichael, what's the square root of 16?
8.
Be careful. What times what is 16?
4.
4 times 4 is 16, so a group of 2 makes this just 4. Very good. What's the square root of 25, Logan? 5, because 5 times 5 is 25, right? I'm out. The square root of 36, Lindsay? 6, because 6 times 6 is 36. So I'm not going to do the rest of these. I think you guys kind of have that concept for these perfect ones underneath there. So if you want to write the rest of the answers down, you can. But whenever you're ready, go ahead and flip to the next page. I'll wait until all of you have it copied down. If you can't see something or a certain color, just let me know. Or if you're in the back of the room and you can't see, let me know. I just put you guys in a scene chart. I have no clue where you can see from. All right, so let's kind of talk about what a radical expression is. So a radical expression is any expression containing a radical symbol. This is the radical symbol here. So for example, the square root of x. X itself is called the radicand. So that's the number underneath the radical. Number, variable, whatever. So number or variable under the radical. And the square root of x is called the radical or the square root. So you guys may have also learned, just as a side note here, you guys may have also learned about other radicals last year, like this one. What was that one? Do you know what that's called? Anyone? Cube root. The 3 out there makes this a cube root. Ian, what's your name again? Hunter, okay. And I'll do one more. These are just side notes. We won't be dealing with these today, but what about that one? What is that one? Anybody know what that one is? That's called the 4th root because there's a 4 there. So that one doesn't have like a special other name. So this is the 4th root. Okay, so just a little side note to build off of some of the things you guys did last year. We're going to do some examples on the next page. Remember, we're going to use factor trees. So before we get to the next page, with a square root, a perfect square means 2 of the same numbers are being multiplied together, okay? So if it was a perfect cube, it would be the 3 of the same numbers being multiplied together, so you would look for groups of 3. If it was the 4th root, you would be looking for 4 of the same numbers being multiplied together to get a perfect 4th. So we're only dealing with square roots. So our goal with this next page is to do a factor tree and look for 2 of the same numbers and circle them. Anything that is circled will go outside the radical, but sometimes they don't have partners, meaning it's not a perfect square, okay? So if there's not a partner, it gets stuck, and it's stuck underneath the radical because it's not a perfect square, all right, just so you guys are aware. So let's get started here. So how do I simplify radicals? So start with by doing a factor tree. So the first step is to do your factor tree. So give me something that multiplies to be 50, Greg.
5 and 10.
Okay, when I get to a prime number, I circle it. Prime means that it's only multiplied by 1 in itself, just so you guys remember that. So what are some factors of 10, Daniel? 2 and 5, both are prime numbers. So then I list out my numbers. We're saying 2 times 5 is the same thing as 50. So 2 times 5 is the same thing as 50. Since this is a square root, we're looking for groups of 2. So look for groups of 2. Okay, so do we have any groups of 2 in this one? Austin, do I have any groups of 2? Which ones? The 5s. So the 5s are a group of 2. So if it is circled, you take one out, and it goes outside the radical. Just so you know, you guys are going to have to be able to do this without a calculator. Sometimes we do no calculator parts of tests for that reason, because some of your calculators will simplify this for you. No circle means it stays under the radical. So who thinks they know how to write up this answer then? How would I write up this answer then? Based on what I just wrote there for step 3. How would I write it up? Jill?
You would write the 5 on the outside, and then you put the square root, and then you put 2 in the...
Good, and it's 5 square root 2, and that's your answer. You may not put this in a calculator and get a decimal answer. We're doing this because in the Pythagorean Theorem, you're going to be taking the square root of both sides. And I do not want a decimal answer. I want an exact answer. So there's a difference between exact and decimal. Exact, or exact and rounded. Exact means that it's not rounded at all. That is exactly what it is. When you do a decimal, sometimes you have to round it, right? That makes it not exact anymore. So that's why we're going away from that. And when it's radicals, they are never-ending decimals. So we don't want to round. All right? Okay, so let's do the next one a little bit quicker now that we know our steps. Let's see here. Abby, what are some factors of 63? 7 and 6 is 56. Close. Not 7 and 6 is 42, not 56. What did I just say? What is it?
7 and 8.
8 is 56. There you go. There's the 56. You're almost there. One more.
7 and 9.
Yeah, 7 times 9 is 63. So 7 is a prime number. Okay, Hunter, how about 9? 3 times 3. So I'm down to all prime numbers, so I list out my prime numbers. Helena, do I have any groups of 2?
The 3.
The 3s. So since it is a square root, when there's no number outside of it, it means 2, which is a square root, which means you're looking for groups of 2. So since there's no number, it's a 2, and we have a group of 3, or partners with 3. So how would I write up my answer for this one, Ian?
3 off the 10 second, 7 on the second.
And that's read 3 square root 7. Okay? So you guys know how to read that? So this one is read 5 square root 2 or 5 radical 2, whatever you want to say it there, or 3 square root 7 is how you read this. All right, let's do another one. Katie, give me some factors of 132. 2 is a prime number. There's so many different ways to do these trees, so just so you're aware. Desiree, how about 66? Very good. How about 6? Let's see here. Olivia. 3 and 2. Do I have any groups of 2, Logan?
Yeah, 2.
2. Okay. What do we do when there's no groupings? What are we going to do with these 2 numbers? Who knows how we're going to write up this answer? Because this is a little bit different. Not a huge difference, but who remembers what to do in this situation? Devin, do you remember what you do?
You multiply the 3 with
And where does that one go?
it stays underneath.
Yeah, you multiply anything that is together underneath, anything that's left out of the circle together. If we had multiple circles here, we would multiply those together as well. So you just multiply them together. And let's do this last one real quick here, because there's a 6 out front. So 72. Who am I not talking to? Cameron, what are some factors of 72? What? 9 times? 9 times 8? Neither of those are prime. Lindsay, factors of 9?
3 and
3 and what?
3.
Okay, I thought you said 3 and 2, so I was like, just want to make sure we're on the same page. How about factors of 8, Lindsay?
4 and 2.
Okay, so we still have the 4 there, which is 2 and 2. So I have 2 times 2 times 2 times 3 times 3. And since it's a square root, we're looking for groups of 2. So I have 2 2s and 2 3s. Who knows what I do with that 6? What do I do with that 6 that's on the outside? Austin, were you going to say something? Yeah. Who knows what we do with that 6? Lindsay, you want to take a guess? Go ahead and take a guess. Yeah, perfect. So the 2 and the 3 are going to be pulled out, and they're going to be multiplied together. And we have to drop down the 6 and also multiply that. I don't know why I put a 3 underneath. Sorry, guys. So you multiply all those pieces together. So 6 times 2 is 12. 12 times 3 is 36. So we have 36 square root 2. All right, what questions do you guys have there? Okay, go ahead and try the next slide real quick on your own for just a couple minutes here. I'm going to walk around and make sure you guys know what you're doing. I'm going to check just probably one of them, actually, just to make sure you know what you're doing. I make really terrible stars, just so you guys are aware. And then you guys Snapchat them to your friends, and then they make fun of me at practice. That's what happens. Just want to make sure you guys know what you're doing individually. Very good. Try another one. If you don't know what I'm talking about, let me know.
2 to take out here and a 2 to take out here. So it's 2 times 2.
Okay, it's 4 times 4, 8. 16. Try again. It's normal because you're thinking addition. You're not taking one out of every single one. You take all of them. The reason you're doing that is because it's like asking you what's the square root. What's the square root? Okay, so that's square root. It's okay. It's not a good trick. Perfect. Just want to make sure before I tell you what you did. Yeah, good. And then you see, I would put all the numbers that are the same next to each other next time, just because it makes it easier. You don't have to worry about it, but you see how you have two twos. So do a weird circle around them. Always go for the 30. I wouldn't even put it around the 3. Like I would go like this. Okay. So what are you going to take out? How many do you take out of the circle? Just 1, so you're going to have 2. You have another 2, so you're going to have 2. Okay. If there's no circle around it, it's say that the radical. The radical. Okay, so how can you simplify it? There you go. Okay. Does everybody have a star on the first problem? At least, or the last one? Because one of you did the last one first. Okay. All right. So, just to get some answers up here, just in case you did other ones, and if you have any questions for me. The first one is 4 square root of 3. I think 7 root 2 should be the next one. Is that right? Is that what you guys got for the second one? Okay. 108. Oh my gosh, what goes into 108? Which perfect square goes into 108? I'm trying to figure that out right now. So is it 36 times 3? So if that makes sense. And then this one is 10 square root, no, not 10 square root 2, 30 square root 2. I forgot to multiply it. 30 square root 2. So if you got those, you're good. All right? Any questions for me before we move on to the Pythagorean Theorem? All right. So horizontal and vertical distance. So remember, first of all, distance is always, what do you know about distance? Distance is always, think about absolute value. What is distance always? Yeah, positive. So you guys remember that distance is always positive. So when we're talking about the distance from things, you need to put it in positively. You do not have negative distances. Okay, so we're going to find the distance of each pair here. So what is the distance from A to B? So to get from -4 to -2, what is the distance there? Katie? 2. If this is a perfect number line, you would go 1, 2. So the distance there is 2. I'm going to put little dashes in between each of these so it's easier for you guys to see that when I do it. Okay, what's the difference from C to A? So, what is the distance here? From -4 to 6. And you can count that way. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance is 10. All right, Greg, what's the distance from B to D then?
12.
12. And if we wanted to count that out, we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very good. Just to show you how to figure that out. So what questions do you have on that first one? Do we understand what we're doing when we're counting the distance? Some of you will be able to do it without the little jumps. Some of you might need to make a number line every time and do it. I don't care which way it is for you. You need to do what's best for you. Does that make sense? All right. So what about this vertical distance? We have a point at 2, 9, and 2, 3. What is the distance there? What can we do to find the answer for that one? Harmony, what can we do to find the distance from 2, 3 to 2, 9? Subtract which two numbers? Yeah, 2 and 2 wouldn't do us any good, would it? Because we're talking about a vertical distance, and vertical is y, right? So we want to subtract the y coordinate. So one of the things you could say is, okay, that's 9 minus 3, which is 6. What's another way you could have done it? Yeah, Lindsay?
I did the distance from 2 to 9 and then 2 to 3. I got 7 for 2 to 9 and then 1 for 2
Yeah,
to 3.
that's because you're comparing a horizontal distance with a vertical distance. So it's like comparing apples to oranges. They're not the same thing, so you can't do that.
Well, I got 7 and 1 and if you subtracted it's 6.
Yeah, I think that might have just been lucky this time. Sometimes things happen like that. So what's another way you could have figured out the distance? Yeah.
Just kind of.
Yeah. So subtracting is definitely a way to figure it out, but you could always just count it that way. You could have used subtraction from C to A as well. So if you would have done -4, but you have to do it absolute value. -4 minus 6, the absolute value of -10 is 10, because the absolute value is always positive, right? You could have done that from B to D. B to D, -2 minus 10 is the absolute value of -12, which is 12. Absolute value because distance is always positive, okay? That's why I did that. So do you see the kind of different ways you can do it? Again, you are your own person. Some of you won't even have to write anything down. Some of you will want to write the subtraction down. Some of you will want to count the squares. I am not a teacher that's going to make you do one way, but I want to show you guys different ways so that it meets whatever your need is, okay? So any questions there? Okay. So what is the Pythagorean theorem? In a right triangle, so right triangle means that it has a 90-degree angle in it. So one of the three angles is 90 degrees. So in a right triangle, one of the three angles is 90 degrees. So in a right triangle, the side opposite the right angle is the hypotenuse. So opposite means if I drew a line from the right angle to the other one, it's opposite. That's what makes it opposite. Okay? The hypotenuse is always the longest side of a right triangle. That is because it is across from the biggest angle. Triangles can only be 180 degrees. So if 90 degrees is already taken from it, the other two angles are split between that 90 degrees, so they're going to be smaller. So the longest side will always be across from the biggest angle, and the smallest side will always be across from the smallest angle. It goes with that kind of concept. So the two other sides of the right triangle are called the legs. If you're given any two lengths of a triangle, whether it be the two legs or a hypotenuse and a leg, you can always find the missing length by using the Pythagorean theorem. So go ahead and get that written down real quick if you haven't written down the extra stuff that I put on there. And then we will look at exactly what the Pythagorean Theorem is in the last 10 minutes here and do some examples. Trying not to go too fast, though. I use most of the period because of that, because some of you guys will need the extra time to write stuff down. Again, I'll post this to the Google Classroom as well. Okay, so Pythagorean Theorem is a squared plus b squared equals c squared. A and b must be a leg, so this has to be a leg squared plus another leg squared. It doesn't matter which leg is which, equals the hypotenuse squared. So c is always your hypotenuse, because it's opposite the right angle. Okay, so this just gives you a kind of a different way of looking at it. We call one of the legs A and one of the legs B, so you don't have to write out leg squared plus leg squared equals hypotenuse squared every single time. That would be really annoying. So the hypotenuse is called C, and we can just plug stuff into this to solve it. So go ahead and get that written down, and when you're ready, flip to your next page in your packet so I know you're all there. All right, so let's get to some examples here. All right, to do this, we're going to find the distance between the points on the coordinate plane using the Pythagorean theorem. So to do that, you are going to draw a right triangle by connecting the 2 points and going out straight to make that 90-degree angle. So since this is opposite the right angle, this is going to be my C. The other two I'm just going to call A and B. It doesn't matter which one it is. What can we find in this triangle? Because to use the Pythagorean theorem, which is a squared plus b squared equals c squared, we need at least 2 of those variables to be filled in. What can we find based on this triangle? What can we find that can help us here? Cameron? We can find the legs. They're a vertical and horizontal distance, so we can find the actual distance there. This is not a vertical or horizontal distance, so you can't just count the squares, all right? But since we can count the squares here, we can say, well, this is 1, 2, 3, 4 squares of length, and this one is 1, 2, 3, 4, 5, 6 squares of length, which means that we have 2 of the legs. We have A and B. So then we can plug in. So we have 4 squared plus 6 squared equals c squared. So 4 times 4 is 16. 6 times 6 is 36 equals c squared. So we have 52 equals c squared, but we have to have c alone. Who knows how to undo something that's squared? Joe?
I think you divide it by the square root.
Don't divide by the square root, you just take the square root. Okay? So the inverse of squaring is the square root. You had partial there. But I do not want to see a decimal. Do you understand me? That's why we talked about simplifying radicals on those first few slides. So from here, you'll do a factor tree. So I have 2 times 26. And then 2 times 13. Which gives me 2 square root 13 equals c. So I went through that one a little bit quicker because we talked about the simplifying radicals earlier. And that's just your answer. So what questions do you guys have so far on those ones? All right, then let's look at the next slide. So you're just going to draw your triangle in every single time. Call this C here. So what's the length from A to C? What's my length from A to C? Iku, what's my length from E to C? 2. Helena, what's my length from C to B?
7.
Perfect. Okay, so how can we use the Pythagorean theorem then to find that one? What can I do to find it? Daniel, what can I do? What? But are they A, B, or C? What are 2 and 7? A and B. It is not C because it is not the hypotenuse, right? C is always the hypotenuse, which is always the side across from C, or the right angle. So that doesn't work there, so we can plug them in there. So we have 2 squared plus 7 squared equals C squared. 2 times 2 is 4. 7 times 7 is 49 equals C squared. Okay, so you take the square root of both sides. Is there anything that goes into 53 or is it prime? It's prime. So your answer is just C equals the square root of 53. Okay, we're going to do number 2 together. I don't know that we really have to do the back end and look at it. I think you guys can figure it out. It's still counting squares at that point. So we'll do number 2 together real quick and then... Oh, that was a terrible line. Okay. So this is opposite the right angle. So this is C. I'm going to call this C as well. So from B to C, what is my length? What is my length from B to C? Austin, what's my length from B to C? It is 8. And what is my length from A to C, Ian? 1. So are either of those C? Are either of those the hypotenuse? No, so should we plug it in for the hypotenuse? No, they're A and B. So A squared plus B squared equals C squared. We don't know the hypotenuse. So we have 8 squared plus 1 squared equals C squared. So that's 64. 1 times 1 is 1 equals C squared. Take the square root of both sides. So that's 5 times 13. Are there any groups of 2 by doing that, though? So we just leave it as the square root of 65 equals, or 65, not 64, equals C. All right. I'm going to get your homework out to you guys. It is tomorrow. Some of you have the algebra review packet you need to do as well.